Hello, I am Prakrit Krishna Shrestha. Today I am going to apply seismic loads on our previously designed model. So first of all, I'll go to define and then see the load patterns. So now here we have dead, live and wind. We need to add a seismic load. So in the load name, I'll give seismic. The type will give as seismic, self wet multiplier will be 0 and auto lateral load will be IS 1893 2002, and we'll click on to add new load. So now we need to modify this lateral load. Please keep in mind that we'll apply the seismic load on both x and y direction. So for the eccentricity you can untick it, and we are applying the seismic load on the area of Bangalore. So for the seismic zone factor, you need to check the IS code page number 5, IS 1893 page number 5. There you'll see for that reason you'll have this as 0.1 and site type will be 2 and importance factor will be 1. Here we'll do the time period as program calculated, and for the response reduction factor again you can see table 7 of the IS code. It is given as 3 for area, for that area. Press OK. Now we need to see the load combination, so go to define and see the load combination. Okay, for these load combinations are already assigned for seismic loads, so you can click OK. Now we need to analyze the model, but first we need to see the which load cases we need to run. Here for the wind load we'll set it as not run, so we'll press do not run, this one for wind, and then for dead, live and seismic it will be run, so press run now. Analysis is taking place. So this is the deformed shaft after analysis. If you want to see some characteristics, then you can go to display and then force stress diagrams. Here you can see the shear force or bending moment diagram. You can press shear to apply. Okay, these are the shear forces acting. If you want to check the bending moment diagram, then go to force stress diagrams and then Ampere. Here you can click to moment 33 and apply. Okay, yeah, so this is the bending moment diagram. If you want to see the stresses applied, you can go to display, force stress diagram and cell stress forces. F11 apply. Okay, so these are the stresses. Now we'll go to design part, design, concrete frame design, and go to view revise preferences. Here the design code shall be IS 456 2000. It's alright, so press OK. Now again to design and concrete frame design, and we'll start the design check. Analyze and design section default for 2 concrete frames. Yes, we will iterate. Okay, I think all the members have passed. So to check that, go to design, concrete frame design, and do verify all members. All concrete frames pass the design check. Okay, now we can see the report for this analysis. You can go to reports in the left side of the panel and go to reports, project report, and summary report. This is the project report that ETABS has self-generated. You can see all the structural data, properties, assignments, loads, analysis results in this report. By this we come to the end of seismic analysis of this tall building. Now we will move on to the dynamic analysis of the building. We will be doing dynamic analysis of the building by response spectrum method. So this method will give the maximum response of the building. So let us start. At first we need to see the load patterns. We need to check if seismic load has already been defined or not. Since we had already defined seismic load, no need to do anything. Press OK. Now we need to go to define and then go to functions and then go to response spectrum. Here this in choose function type to add, we shall go to IS 1893/2002 and then go to add new function. Here function damping ratio will be 0.05. Function name we shall give as a response spectrum. Response spectrum. And seismic zone factor, as we did before for area of Bangalore, it was 0.1 and soil type was 2. Now all other things will remain same. This is the function graph of the response spectrum. Now press OK. Okay. Now we'll go to define and then we will see the load cases. And since this is evaluation version, first we need to delete this win load case. Okay, now add new case. Load case name will be response spectrum. Load case type will be response spectrum, and then in the loads applied we shall go to add a new load. Load type will be acceleration, load name will be U1, and function will be response spectrum. So now here we have scale factor. Scale factor is I into G by 2R, where I is importance factor, G is acceleration due to gravity, and R is response reduction factor. Here we have the value of I as 1 and G as 9801 mm per meter square per second square, and value of R is 3. So after calculating we get that value of scale factor as 1633.5. Now again, and we need to add another load type, which is acceleration. Load name will be u2. This is for the another direction, be response spectrum, and scale factor will be same for the same building. Now in directional combination type, we shall go to CQC3. Model damping will be constant at 0.05. Diaphragm eccentricity 0 for all diaphragms. Okay, this has been added. Okay, now we shall go to analyze and see set load cases to run. For the response spectrum analysis, we do not need to run dead load, live load. So we'll do not run. Similarly for live load, do not run. And seismic and response spectrum will do as run. And now so now our model has become analyzed. This is the displaced building. If you want to see some of the properties after these loads have been assigned, you can go to display and then see story response plots. Here story response 1, case combo, you can go to seismic and see the displacement in each story. Okay, blue is in x direction and red is in y direction. Similarly for maximum story drift, you can go to display type and see the maximum story drift. Our building has come in this way, drift has come this way. So maximum drift is 0.000619. According to the rule, the maximum story drift should not exceed 0.004 into story height, that is 3 meter. So our maximum story drift doesn't come excess. Also you can see for the case combo of response spectrum, it comes like this. Here also the maximum drift is not exceeded, so it's okay. If you want to see other things, you can go to display, show tables. I'm sorry, you can go to display and then show tables. In analysis and results, you can go to structural output and here you can click base reaction. So okay, so in the table form you will see the reactions in fx, fy, fz and moments. Now for the design part, go to design, concrete frame design, and check for revised preferences. Design code is set as IS 456-2007. Okay, again go to design, concrete frame designs, and now we'll start design check. So 2 concrete frames did not pass. We can reiterate it. Yes. I think all the members have passed now, so we can verify it. Go to design, concrete frame design, and verify all concrete frames pass the design check. Okay. As before, you can see the report from this section. So now we come to end of design and analysis by response spectrum method. Now we are going to do dynamic analysis by time history function. Uh, some time history data is required to perform dynamic analysis of this building. First of all, you need to ensure that you have defined seismic load. We have already defined it. Still, go to define and then go to load patterns. In the seismic load, go to modify lateral load. Here, while doing time history analysis, we need to provide direction in only one direction, so on tick y direction. All other factors are same as before. So okay. Now again go to define and functions, go to time history. So in function type, we need to add any function from previous or any data of earthquake. Here we are going to take data of 2001 Bhuj earthquake of India. So I've already downloaded that file. So go to from file, add new function. Here go to browse. I've already downloaded this data. Okay. Now in format type, go to fixed format and characters per item is 10. Now you need to view this. You can view the file from here. This is the report of 2001 Bhuj earthquake of January 26. Here header lines to skip is given as 2. We need to count number of lines which to skip. 1 2 3 4 5 6 7 8 9. So 9 lines we should skip because the actual data starts from here, 10th line. So lines to skip will be 9. And number of points per line is 1. Okay. This is the function graph of that earthquake. Okay. Now again we need to go to define and in load cases. So response spectrum we can delete for now. Add new case. So this new case is time history function. So give name as time history function. Load case type will be time history. And here in loads, we need to provide only one load. Load pattern is acceleration. Load name u1. Function will be scale factor is as before. We need to calculate this value. And model damping is constant at 0.05. Okay. Now the load cases are dead, live, seismic, and time history function. Okay. Now go to analyze and go to set load cases to run. So in action there it's already dead and live are already do not run. We should set it for do not run, and for seismic and time history function we should keep it as run. Now you can perform the analysis. So this is the displaced model of the building. To see any plot functions, you can go to display and see the plot functions. This is the force and time graph. Load case time history function. To see the response combined story response plots, you can go to display and see combined story response plots. Here you can see the displacement, drift, shear, and overturning effects. Maximum drift you can see here as 0.000157. This should not be more than 0.004 times the story height. Any other things you want to see, you can go to display and see from show tables. Now I'm not going to see those. We can go to design part, go to design, and go to concrete frame design and see view revise preferences. Design code is set as IS456. It's okay. Again go to design, concrete frame design, and now we can start the design check. Two concrete frames didn't pass. Reiterate again. Yes. I think all the members have passed. You can check it. Go to design, concrete frame design, verify all concrete frames pass the design check. Okay. Now for the report, you can in the left section you can go to reports and see the summary report. you'll get all the information there. Also, for some sections you can click it at any beams or columns, and then you can go to details. Here you can see all the details of that member. By this we have come to the end of design and analysis by time history analysis. Thank you.